Chapter 7, which is called Ellipse Generator Mechanism. I've assigned this thing as a problem to do for the coming homework. Anyway, it looks like that. It's made of a base and two blocks in it, and then there is a rod which is going to be inserted into the top holes of those blocks. Okay, so we have 1, 2, 3, and 4 parts all together. Okay, so let me go ahead and do that for you. Let's start with, I'm going to totally ignore the dimensions, so insert, let's start with a new product file. Okay, so insert the base, insert new part in there, and let's call this thing the base. So that's going to be properties, we call it the base, and the base. Alright, let's make it. So double click on a convenient plane on that top horizontal plane. I will make a centered square type thing. Okay, and exit, and let's pad this. Okay, that's good. Alright, so on this front face I will sketch a rectangle. This is to create the let's say the tracks. Okay, so let me see now. Alright, so centered, so that's fine. Exit, and we make a pocket. So all the way through, all the way to the last. Okay. Now what I would like to do is I can make another pocket just like that, which is going in the Y direction. However, I will actually use a circular pattern feature to save a little bit of time. So here we are. So we have a circular pattern, and we want a pattern complete crown. 2 instances. Now for the thing that we want to pattern, I'm going to select this pocket, and for the reference element I will select the Z axis. The different ways of doing this thing, but or I can select the top face, it doesn't matter. It's just that perhaps this is not working the way I want it. So let me cancel that. Okay. So what I'm going to do is I create a coordinate system here. Let's see now, where is the coordinate system? Right there at the origin. You can see that at the origin. And now try to do a circular pattern of complete crown, 2 instances. Let's do complete crown, 2 instances, and for the thing that I want to pocket, I choose that pocket, and for the reference element I select the Z axis there. Okay, and that should do it. Actually, let's find out. Preview. Okay, so why is this thing not working? Complete crown, that's this is 5. I guess the complete crown is not a good idea. Cancel. Notice that it is easier if you drew this thing on that side and then just pocket it, but I insist on using a crown. Okay, so let me try it one more time. complete circle. Circular pattern, but I'm not going to use complete crown. So let's try something else. Let's try instances and total angle. Okay, and angular spacing, instances, angular spacing. So let's try this. 2 instances, angular spacing. Let's make it 90 degrees. And for the thing that you want to pocket, you want a pattern, use a pocket. And for the reference element, I use Z. Okay, there we are. All right. I'm sorry, but at least maybe you get to do it a different way. Okay, fine. So now let's go ahead and insert our next part. So one of these blocks. So insert new parts. Let's see, a new part in there. Say no, and I'm going to call it block. Right click properties, and we call it block and block. Alright, let's make the block. Double click on this. So I want to make a block which is exactly this size. So on a convenient plane, on that plane, I will sketch. Alright, since I want a block exactly with that size and I don't have the dimensions either specified or recorded here, here's what I'm going to do. I'm going to project this edge. Let me see, did I do it? Let's try it again. Okay, let's try it again. Project this edge. Is it doing it? Let me see, I'm not sure if it's projecting it. Oh yeah. Okay. Let's try the other one. What's the saying? Project 3D element. Okay, yeah, that's good. That's good. So is it projecting it? I'm not. Oh, there they are. That's projecting it, but the plane is actually on the other side. That's okay. You may have too many of these. That's all right. So let's see now. Let's look at the normal direction. The normal direction here, right there, and let's complete these blocks. So let's see now. We want. I hope that there's only one projector there. I'm not sure. Maybe there may be other ones. Actually, probably there are. Let's find out. Okay, so we have several curves here. These are. Let's see now. This and that. That's okay. This is a curve. Okay, these two. I think I would like to delete one of them. So let's see now. Delete this. Let's go to this part. Okay. We may have multiple lines here, which is going to cause a problem later on when we try to. Yeah, you can see that. See? Okay, so let's see. I'm not sure. Let me delete this. Maybe deactivate it because if you deactivate it, they're all going to go. So let's get it back. So let's take this. Let me see if I can delete that. Yeah, it doesn't look like it. Let's go ahead and see what we can do. We're going to go to that sketch. There we are. Okay, so perhaps the best way of doing this is to deactivate these things, or turn them into construction entities. So construction, and you can see there are multiple versions of this. So yeah, let me delete this. Okay, this is turned into construction, and let me delete this. And okay, so now I'm going to project that. Okay, there we are. I think both of these are constructions, as you can see. Right click property. Let's write this. Yeah, good. So all right. Okay, let's complete the rest of the profile. Maybe I hide this. Okay, so let's do the rest of it. Profile from here to there, and this I don't want it to be a construction, so put this to that point, and there we are, and there, and there. I didn't really even have to project. I could have drawn this thing and used coincidence to get it to work. So let's see. I made my work more complicated. But that's okay. Alright, so let's pad this. Yeah, that's good. And on top of it, I'm going to draw a circle. That's where the pins for the rods are going to go. And you can always center it too, but I'll just leave it the way it is. Exit. And make a pocket. Alright. Good. Now, the other block is exactly the same size, same shape. So that being the case, what I can do is I can save everything and use an instance of this part. Or you can make it again if you want. So File, Save Management, Save As, Desktop, New Folder. So we'll call it Ellipse Generator. Ellipse Generator. Generator. Okay. And then I'm going to do Insert, Existing Component. And it says, okay, where's that existing component? Well, it is on my desktop. I created the Ellipse Generator and I saved the block in it. So let's just give it a second. The block is put in there and they're sitting on top of each other. So if I go to Assembly Design and trying to move these, you can see that. So I move it along the X direction. There we are. Okay, and actually let's also move this thing along this one along the X direction. Yep. Good. All right, so let me go ahead and make the other piece. The other piece is the rod. Okay, so insert new part. Say no, and this is going to be the rod. Properties. Properties. I call it the rod. Rod and rod. Okay. Let's make it. On a convenient plane, on that horizontal plane, I will draw, well, something very simple. So the rod is basically a rectangle, like that. And it's got two circles in there, which are going to turn into pin. I use Multipart to do that. Okay, now, okay, so why don't I take this and also make it on this side. Let me try to use the translate option. See if we can find it. There's the translate. Read this thing. So there's going to be one instance, and let's make sure we read this thing carefully. This is what I want to translate, and I want to translate it to this location. Okay, there we are. Exit and do a multipart. You may want to fool around with the translate option if you have never used it. Or either that or make the circle yourself. So let's try the multipart. It's a lazy way of doing it. Okay, so we have three curves here. This is the entire rectangle. Let me give this thing point. Let me make this thing by 0.3. It looks like. Yeah. Okay. Good. And this one by 0.5. 0.5, and the next one by 0.5. If you want to hold it, just give it 0, but we want a pin, so there we are. Okay, now we are ready to assemble everything. So let's go there. Let me collapse the tree so that it's easier to keep track of things. All right, we go to the assembly design, we save everything, anchor the base. This was the base. Now let's position this thing in that track. So between, all right, let's say this edge and that edge. Okay, and coincidentally this plane and that plane. Okay, so if I move this thing to a more reasonable location, it looks like that. Now let's put this block in that track. So coincidence between, say, this edge and okay, that edge, and coincidence between, I don't know, maybe this plane or and I guess that plane. If it doesn't work, we'll fix it. So let's see. Update. Yep, that looks good. And let me translate this thing in the direction Y so that it ends up in the track. Oops, wait a minute. Uh-oh, I think I have the wrong orientation here. So let's try to fix this thing. Cancel that. This last constraint, I'm going to delete. Last two constraints, I'm going to delete. It's the faces, I think, that I have a problem with. So just to make sure, I'm going to delete this and delete that because I can't really see what I've done here. So coincidence between, how about this edge and that edge? Yep. And coincidence between this plane and that plane. Let's update. Yeah, I think that looks better. Except that it has to be on the other side. So that last constraint, I double click, flip the arrows. Do I do that? Yep. And update. Okay, good. So let's move this thing to position. There we are. And let us now insert these into those holes, these pins into those holes. So coincidence between, let's say, this axis and that axis, and coincidence between this plane and that plane. That makes it a revolute joint. All right, let's flip the directions. Flipped it. There. Okay. And now put this pin into that hole. So coincidence between this axis and that axis. It doesn't matter whether we make a coincidence between the planes, because in one situation it becomes a cylindrical joint, in the other revolute. But the constraint here will always turn the two faces mating. All right, so let's update this. All right, good. Now let us first of all check and make sure that our constraints are holding. So let's check this box and let's say rotate, revolve about a particular axis. So I don't know, that axis perhaps. And let's check. Yeah, you see that? That's the way it should work. Okay, very good. Say close. Okay, so let's go ahead and create the. My battery is dying, so let me plug this thing in. All right. Okay, good. So what we're going to do is we go to Digital MockUp, DMU Kinematics, get the magic wand out, new mechanism, auto create, Let's check the degrees of freedom. This should be a single degree of freedom system. Yep. And we can make one of these revolute joint or the cylindrical joints angle driven, as if there was a motor sitting there which is turning continuously. So I make it 0 to 360. Obviously, mechanism can be simulated. So let's go ahead and do that manually. Okay, very good. And obviously you can do that, make a cartoon out of it, so or animation out of it without any physics. Insert, rewind, and change it to anything but 1. Now the next thing I want to do is to show you that actually the tip of that rod traverses an ellipse. Okay, so let me stop this. Now, in order to get the trace of this point, you have to first create a simulation, and we just did. Okay, then you have to compile it. Unfortunately, without compiling, what I'm going to show you is not going to work. So where is the compile? Right here, the same place that you created the animation or the cartoon right there. The next one says compile. Compile, and all we want to create a replay. I don't want to create a video file. So just do replay anything but 1, and just play it once. Once you create this replay, which is here, incidentally, and you can always use it whenever you, if you save it, whenever you want, you can come back and play it. There is an icon here which looks like the trace or footstep. See if I can find this thing. Let's see. Oh, right there. You see this? See that icon here? It says trace. You click on it, and it says, okay, what is the element to be traced? So it's this tip that I want to be traced, the tip of this rod. And it says, how many steps do you want when I trace this thing? How many points do you want I generate? Now, if you put, maybe 10, then it's going to be 10 points. If you put 50, it's going to be more points. And then you can create it as a new part, which means later on, once you save it, you have to insert it. If you don't say a new part, I guess you have no choice. You have to say new part. Okay. So we say all right, and there we are. It just created it on the trace 1. So let's save this thing. File, save management, save as. Actually, notice that it is in the same folder. So all we have to do is to save the product. Everything is going to be saved with it. All right. Now I can close this. It's already saved, I think. Let me check. File, save management. Oh, I guess, yeah, I guess I have to save the part. Save as in that same folder, and then OK. Now I can close this, and over here I can say file, insert existing component, because I saved it. I can access it in there, and it's the trace that I want to insert right there. You can see that, and then we can go to replay and play it. There we are. So the tip of that rod traverses an ellipse in the event that the location of this pin, the middle pin, is exact halfway between the other pin and the end, or the end of this rod, then that's going to traverse a circle. Otherwise, it's an ellipse. Now, I didn't put any physics in here, but you can do that yourself, or you can go ahead and read you really should read the chapter in the book and find out. If you specify the speed of, for example, this revolute joint. Let's say that a motor was sitting there, then what is the speed of the point, or create some sensors, etc. So I leave it to you to work it out. Okay, and let's stop this thing. Good luck.